Now we're on to long division of polynomials. This is one of my favourite topics because it can be pretty fun to do once you get the hang of it. The idea is, as you're going through, it's essentially the same as what you were doing with numbers, but now you're just doing it with polynomials, basically. You're going to be doing a little bit trickier steps, but the good thing is they are repetitive. It's like a loop. So once you can really comfortably do the step once, you can actually get through the whole problem because you just keep doing it in iterations. Now, I'm not going to read these steps because it's going to be too hard to understand them without seeing an example first, but these are there just in case you wanted to put them into your notes. And these tips I'll just mention now. We're going to make sure we keep mind that we're going to match everything up in columns. So we'll have the x cubes lining up with the x squares, lining up with the x's, just like you would line up the columns in your long division of numbers. And we're also really going to have to use brackets whenever you're expanding and subtracting anything. So I'm going to start by writing this out the same way you write out your long division of numbers. So we get that long division symbol, and on the inside of it we write the dividend, the thing we're going to be dividing. And then on the outside, we're going to write the x plus 1, which is the divisor. Okay, this is the divisor. This is the dividend. Now, I'll read through these steps. Hopefully this will make sense as we go, but it'll probably take a few times for you to get used to the idea. This is saying, how many times does the leading term of the divisor go into the leading term of the dividend? So let's find those terms. Let's start with the leading term of the divisor. That's the x, right? That's the leading term of the divisor. How many times does that go into the leading term of the dividend? This is the leading term of the dividend. The question is saying, how many times does x go into, how many times does that go into x cubed? So what, or another way of thinking about it, what is this x multiplied by to get to x cubed? I like to think of it like this. What is this x multiplied by to get to x cubed? And the answer is x squared, right? You would multiply x by x squared to get x cubed. Great, we have now done the first step. Step 2. Add this, and by this I mean the x cubed. Go that to avoid confusion. Add this x squared, not x cubed, pardon me. Add this x squared to the quotient. Okay, so let's start by just doing that. We're going to put it up in the quotient and match it up with the correct column. We're matching up the x squareds. We've added this to the quotient, then multiply the entire divisor by this value. Okay, let's do that. We're going to multiply the divisor, x plus 1, multiplied by that value, which is x squared. So expanding this out, we get x cubed plus x squared. Good. Multiply the entire divisor by this value, we've left with this, and write it underneath. We're going to write it underneath this, just like when you write your long division of numbers, you write it underneath and you kind of build downwards. So we'll write it underneath and we'll match up our powers. Okay, that was just me writing that from underneath. Good, I'm going to clear some space because we're up to step 3. Subtract the product from step 2, so that's this product. Subtract that from the dividend. So I'm going to put a minus there to show we're subtracting. This difference is your new dividend. So, okay, so we'll get to that in a moment. We're subtracting this, so let's go through that now. This is where our next tip comes in. Use brackets, okay? So I'm subtracting not just the start of that, I'm subtracting the whole product. The entire thing that we've calculated is getting subtracted. So I need to put brackets around it and I need to put the minus at the front of the whole thing. Okay? Now let's go through and subtract. We do x cubed minus x cubed. Well, that's just 0 because 1x cubed minus 1x cubed, they disappear. And that's actually what we expect. what we're doing when we're going through long division is gradually killing off the powers one by one until we should be left with just one number or one short little expression here. We're slowly cutting down on the expression and making it smaller and smaller. So you're expecting every time you subtract for one of the powers to get killed off. If it doesn't get killed off, that's probably a mistake somewhere in the working out. Okay, so these get killed off. Perfect. Then we do 7x squared minus x squared. 7x squared minus x squared is equal to 6x squared. Okay? Let's see what the next bit is. This difference is now your next dividend. So we just bring these down because we haven't really done anything with them. They continue. And now we have reached step 4, which says repeat the process. So now this is our new thing that we're looking at, and we're going to do the exact same steps over and over again until we reach a point where it says here where it no longer fits into the dividend. So once we get a point where it's no longer fitting, then the leftover is the remainder and we're basically done. So I'm just going to close this. You'll probably want to add this to your notes, but I think it will be easier for us to just try to do this with a bit more intuition for this next step. I'm going to erase this 0, make it a bit easier as well. Okay, so now we're up to how many times does x go into 6x squared? So we're looking at the leading term and the leading term. How many times does x go into 6x squared? Well, we can write that on the side. X times what is equal to 6x squared. X would have to be multiplied by 6x to give 6x squared. And so I'm writing it in the quotient, matching up with the x column. I'm writing the 6x that would be in here. Now the next step is to grab that thing that we just wrote up the top and multiply this whole divisor by that. So let's do that on the side as well. We're doing 6x times the entire divisor, x plus 1. And expanding that out, it's 6x squared plus 6x. Good. Now we put this and we put it underneath our line here, matching everything up. So we put 6x squared plus 6x underneath and we subtract it. So we put brackets around it and we subtract it. Okay? And as you can see, 6x squared minus 6x squared kills off the 6x squared again. So we've deleted, we've basically gone through and crossed off another column. This is fantastic. That's a really good sign. So now we have 10x minus 6x. That should be 4x. And then just drop down the 8 plus 8. So you have to be careful with this minus that you don't accidentally do. It is very easy to think plus and then just end up with 16. You have to really carefully look at the minus on the side and make sure that you're expanding that negative to apply to all of the terms in the brackets. That's why the brackets are there. All right, we are up to repeating the process once again. So we grab our leading terms, which is x and 4x. What does x have to be multiplied by to give 4x? Well, it would have to be multiplied by 4. So we pop the 4 up here. Then we multiply the 4 onto the entire divisor. So we do 4 times the entire divisor, x plus 1. And that gives us 4x plus 4. Okay? And now we write that underneath, 4x plus 4. We put the brackets around and we subtract that down away once again. We go 4x minus 4x. Fantastic, that disappears once more. That's what we want to see. And then 8 minus 4 is equal to 4. Okay, very, very good. Now we've reached a point where if we tried to do this again, we would say, okay, how many times does x go into 4? And if I tried to write that, what does x have to be multiplied by to give 4? This has to be a polynomial for this problem because it's all about polynomials. And there's actually no polynomial that you can multiply x by to give 4. You would have to get rid of the x, which would involve dividing by an x, and that's not a polynomial anymore. So we've reached a point where we have to stop. There's no more division that we can do anymore. And that means that we've finished the problem. Let me show you what that means. Just going to clear this up. We've stopped because we've reached a point where the divisor no longer fits into the thing that we've written here. Therefore, this is the remainder. And this is the quotient. This quotient up here is the number of whole times that the x plus 1 fits into this dividend. Okay? I'm going to show you how you can check your working, and at the same time it should hopefully give you a bit more intuition about what's happening. So when we did this same problem with numbers, we had this expression, which is that the dividend is the same as the divisor times the quotient plus the remainder. If we write this out with our polynomial, we should get the same thing. So let's try. The divisor times the quotient plus the remainder. The divisor was x plus 1. The quotient is what we've calculated. It's x squared plus 6x plus 4. And the remainder is the number that's left at the very bottom here, the number 4. That's the number that we couldn't fit anything into anymore. Now we can go through and expand this out. So we'll do x cubed. X times 6x is 6x squared. X times 4 is 4x plus 1 times x squared, 1 times 6x, 6x, 1 times 4 is 4, plus the 4, don't forget to add that 4 from outside. Okay, and now just grouping our like terms, x cubed plus, this is like with that, so that's 7x squared plus, this is like with that, 10x plus 4. Okay, what does this mean? If you have a look up here, that is the exact same thing as our dividend. This is exactly the same. We have x cubed, 7x squared, 10x plus 8. So this is the exact same as the dividend. Okay, so this is a good check to do, because if you can expand it and get back to what we started with, that means that you've written out the quotient and the remainder correctly, you've done all these steps correctly, and you've completed the problem. Okay, well done. This was a little bit probably information overload, but I encourage you to go through and just recognize that the steps are the same each time. If you can learn the same 4 steps and repeat them, then you can do this for as many steps as you need. You could do like x to the power of 100 and all the way down from there. It will be a very long process, but it's the same process each time. So if you learn the steps, you can do any kind of problem like this, as long as you remember the steps and as long as you're being a bit careful with your columns and you're expanding.